morning to one and all. This is CHV Krishna Mohan, working as an assistant professor in Computer Science Department, AAML specialization. Today, I want to discuss what is a register and the register micro operations. First, we'll try to see what are the list of topics we are going to see in Unit 3. Previously, we have discussed what is Unit 1 and what is Unit 2. So in that we have seen what is a digital computer, how a digital computer is constructed, and how it is organized by assembling different types of components. Once if the digital computer is connected and organized, we have to see how the operations are performed. If the operations are performed on a digital computer, how they are performed and what components we are using to use that particular operation. So here comes this Unit 3, where we will try to define what are the components required for executing a micro operation. So basically we try to see what are the list of components we are using here for register transfer operation. First unit or the first component here we are going to see register transfer language, register transfer. Next we will see bus and memory transfer, types of micro operations, arithmetic operations, logical operations, shift operations, and finally we are going to see arithmetic logic unit. So all these components cover how the registers are going to be built and how the operations are executed on the registers. Suppose if I want to execute an operation on a register, what I should do? So what type of operation I should write and how that operations are operated. Suppose if I want to say, I want to add two operations or two registers data. So what I should do? Suppose if I want to multiply or subtract, how these things are to be done, this everything we are going to discuss in register and micro operations. First we will see the definition. So what is a register? And once after seeing the register definition, then we'll see what are the types of registers. Once if the types of registers are covered, then we'll try to see how that registers are operated by using some micro operations. Right. A digital system is an interconnection of a digital hardware component. Suppose if I say it as a digital system, it is a connection or it is a collection of different types of components. See, when I say it as a digital computer, it is a connection of 5 components. It is a connection of 5 components. That is, we'll connect one component as an input, second component as an output. The third will be the control unit, ALU, and the memory unit. So majorly these 5 components comprises of a digital computer. So when I say it as a digital system, it is an interconnection of different types of components. So basically we have these 5 components. So these 5 components are connected and these 5 components are considered as a digital system or a digital computer. The various modules which are connected are considered as this input output, control unit, memory unit, and ALU. Right. The operations executed on the data stored in the registers are called micro operations. Right. The register stores a small bit of informations. Basically, if I say what is a register, the register stores some small bits of information where if I try to apply some operation on that data, if I apply some operation on that particular data, that data is going to be executed and it is going to give a result as an output. So what type of operations are considered as micro operations? When I am executing an operation on a register, suppose if I have some data on a register, I should apply some operation on that particular data. Some 2 bits of information is there on the register and I am trying to apply some operation on that. So that operation may be an addition operation or a subtraction or a multiplication, or it may be some logical or shift. If you are trying to apply any type of operations, that particular operation is considered as a micro operation. See, a micro operation is an elementary operation performed on the information stored on the registers. The information stored on the registers, if you are applying some operation on the information stored on the registers, that is considered as a micro operation. Right? Next, the results of the operation may be replaced previously with some binary information of the register or may be transferred to the other associate. When I say it as a register, suppose take a register as a register R. The register can store the information or the register can process the information. Right? If I take it as a register R, I can store some data on the register, some 3 bits of information or some n bits of information. Parallelly, I can try to do some operation on that particular register. Suppose if I want to add some bits of information which is stored in R to R2. Now I can combine or now I can add register R plus R. So this is considered as an addition operation. Likewise, we can try to do some operations which are stored on the registers, some bits of information stored on the registers. Means we can store the data on the register and we can try to do some operations which are stored on the information of the registers. Next, we'll try to see here what is this RTL. RTL, Register Transfer Language. Generally, if I'm trying to do some C language or some any type of programming languages, we used to write some syntaxes. We used to write some syntax and we used to operate these syntaxes and by doing some methods or by applying some operations on that to get an output for us. The same thing here also, if I want to do some operation on the information stored on the registers. As I told you, bits are stored in the registers. On these particular registers, I have to do some programming language or I have to do some language which is called as RTL, Register Transfer Language. What this language will try to do is, instead of narrating a long information, see here the symbolic notations used to describe the micro operation transfer among the registers. Suppose if I want to do some operation that is transfer of information from one register to another register. I have a register R1 and I have a register R2. If I want to transfer the register from R1 to R2, I should write some lengthy code to transfer the data from register R1 to R2. Suppose if I use this RTL, that is Register Transfer Language, here simply I don't try to write any narrative explanations. Simply I don't want to make use of a long sentences where I can directly use some symbols, where I can directly use the register notations. By using these, simply I can try to transfer the data between the registers. So to do that, we have to use or we have to implement some language which is called as Register Transfer Language. Right? Next, what is the registers and how they are designated? We are telling it as registers. Registers contain some information and we are trying to do some operation on that particular information. Suppose if I am telling it as a register and a register contains some information, it should be represented in some particular format. So computer registers are designated by uppercase letters. Basically, first we have to see how these are represented. First I should know how these registers are represented. Once if the registers are represented, then I can say how the operations can be carried out. Computer registers are designated by uppercase letters. Means I can write a register R1. I can write a register as R1. Suppose again if I want to register another register R2. Right? In this way, we are trying to represent the registers by capital letters or we can say it as uppercase letters and followed by digits or letters. See here I am writing it as 1, 2 and I am writing it as 3. Means if I say it as R1, it represents a register first or first register, or if I say it as R2, second register, R3, register number 3. In that way, we are trying to represent the registers in particular format and denoted by the function of the register. Suppose if I want to do some function on that particular register R1, or suppose if I want to do some function on the register R2, I have to add some symbols to that particular register where it denotes this register is going to perform some operation. For example, the register that hold the address from the memory unit is usually called as memory address. Suppose if I am trying to add some registers in the memory unit, I have some set of registers. I have to store these registers, or I have to place these registers in the memory unit. These registers are designated by MAR. MAR. So this we will call it as memory address registers, because these registers are getting stored in the memory unit. Likewise, we have n number of registers which are stored in a digital component. Next, other designated registers, for example, if I say it as program counter. As such, if I take it as a memory register, means we are designating it letter MAR, memory address register. Suppose if I say I want a register which is called as program counter, that I will designate it as PC. If I say it as a PC register, means program counter register. So what the program counter will do? The program counter will try to make an increment of the iterations. PC is equal to PC plus 1. PC is equal to PC minus 1. Suppose if I want to do some increments and decrements in the register transfer language or in the micro operations what I am performing, then I can go for program counter. Next, if I say it as instruction register, if I want to pass some instructions, so to what registers I should pass those instructions? So those registers are designated as IR. Right? So in that way, we have different types of names for each and every register. Altogether, we perform basically 16 types of registers, where these 16 registers are listed and these registers are frequently used. So we have a number of registers in a digital computer. Other than that, we have to make a list of registers which are performed frequently and which are used frequently for executing the arithmetic operations or logical operations or shift operations. Next. So if I take this consideration and if I say this, how the register is represented. So previously I told you the register is represented with a capital R with a capital letter, which is followed by a number or a symbol. So now if I say it as a register, how it represents in a backend, or if I say it as a register, so what are the register functions and what are the features of the register. First, if I say it as a register block diagram, see, we have here A, B, C and D. So the block diagram of the register contains 4 types A, B, C and D. If you see a register A, it is represented with rectangular box. If we see a register A, it is represented with rectangular box. Inside, if we see, it is represented with R1. That is the name of the register. That is the name of the register. It should be a rectangular box. Inside the rectangular box, we should try to represent a register with some name. That name is considered as R1. Or if I make it as register 2, I can make it as R2. Or I can consider it as R3. So basically, if I say a register block diagram, means it should be with a rectangular form or it should have a name inside by designating with a capital R and followed by a number. Next, if I go with B, see, if you see here, the B contains 0 to 7. If you see here, 0 to 7. So these designate 7 bits are stored or 8 bits are stored in the register R1. A basic register can store 8 bits, right? So it starts with 0 and ends with 7. Means a register contains 8 bits where the designation of the bits will start with 0 and ends with 7. So the representation or showing of an individual bits will be 8. If we go for C, we can see the representation of bits here is in the form of 0 to 15. 0 to 15. Means it is 16-bit register. We have 16-bit register, we have 8-bit register, we have 32-bit register, and we have 64-bit register. So wherever you go, the register representation should be in the form of a rectangular box. Inside it should be having a name with a capital R and followed by some number or some digit or some symbol. Next, if you see 0 to 15. See, this 0 to 15 is a 16-bit register where I can make it into two parts, that is R1 and R2. So numbering of bits can be 0 to 15 or I can make it as 0 to 7. Here, if you see the difference between B and C, B is trying to give all the bits which are in the register. B is trying to give all the bits, that is 0, 1, 2, 3, 4, 5, 6 and 7. If you see C, they are representing only from 0 to 15. Means in the C, they are telling the range. If you go to the B, they are giving each and every bit information in the register, that is 0, 1, 2, 3, 4, 5, 6 and 7. Finally, if I go with the register D, the format of register D, it has PCH and PCL. Means that is partially we are trying to divide the register into two parts. That is left hand side and right hand side. That is the left hand side starts from 8 to 15, that is 8-bit register. That is 0 to 7. If I go to the right hand side, it is 0 to 8-bit register. Means one bit is divided into two parts, that is 0 to 7 and 8 to 15. So in this way, we can try to represent the register in a block diagram with A, B, C and D. Right? Next, the most common way to represent a register is in a rectangular box. I think we have seen all this. The individual bits can be distinguished in B. Likewise, C is going to give the range. And if I go with the D, D is making the equality partitions when I go with the register. Next, see, we have seen what is the register and how the operations are performed on the register and how the register is represented. In what way we are going to represent the register. Now, we'll see how the transfer of data will be between the registers. How the transfer of data will be between the registers. Information transfer from one register to another register. Suppose if I am transferring the data from one register to another register, how the transformation should be done? How the transformation should be done? Suppose if I make register R1 to R2, I have some data on the register R1. I am trying to send this particular data from R1 to R2. What should I do? No doubt I am trying to use here an RTL, that is register transfer language. Suppose if I say it as a register transfer language, I told you that we are not going to write any narrative statements, right? We are going to use the symbols. We don't write any lengthy explanations or we don't write any lengthy syntaxes and very large programs to transfer the data between the registers. So RTL gives a very simple or a very modified way of transferring of data between the registers by using some symbols. Suppose if I want to transfer the data from R1 to R2. See, if I say the statement R1 to R2 means the data from R1 is transferred to R2. If you use or if you see this, data from R1 is transferred to R2. Means whatever bits are stored in R1, they are transferred to R2. The transfer of the content from register R1 into register R2. It designates a replacement of the content. Whatever data is stored in register R2 will be replaced by the content of R1. If you see this statement, the data which is stored in R1 is transferred to R2. Immediately, if it is done, the register content which is stored in R2 is replaced with the register data of R1. By definition, the content of the source register R1 does not change after the transfer. See, if you see the diagram here, we have a control circuit, we have a register R1 and R2. Simply, the statement R1 transfers to R2. If I say the transfer of R1 to R2, that we are trying to represent in a diagrammatic format. If you see here, a control circuit is there where when if P is equal to 1. This is a control statement where when if I say it as P is equal to 1, then the transfer of control or the transfer of data from the register R1 to R2 will happen. If I say it as the P is not equal to 1, means if I am controlling that or if I am trying to stop the transfer of data, if I don't want to transfer the data from R1 to R2, simply I should make it as P is equal to 0. Right? In that way, we are trying to use the registers where I can transfer the data from one register to another register. If we see here, we see some symbols where these are the very basic symbols we have to use while the transfer of data between the two registers is going to happen. When I go with the symbols, letters denotes a register. Letters denote a register in the sense, suppose if I say it as R1, I am making it this letter R. Or if I am making it as memory address register, MAR. If I say it as a program counter, PC. So all these are represented as registers, the name of the register. Next, parenthesis denotes a part of a register. If I say it as R2 and R1. See, if I say it as R2, in the bracket I have written 0 to 7, means R2 is an 8-bit register. If I say this, or if I say it as an example R2, in the parenthesis I have written 0 to 7, means it indicates that R2 is an 8-bit register. So in that way, if I want to say the range to any of the registers, I should try to make use of parenthesis. Next, arrow mark. See, the arrow mark plays a very important role in the transfer of data. As we seen in the previous slide, R1 tends to R2 or R1 transfers the data to R2. In the same way, if I use this symbol, denotes the transfer of information. Means the transfer of information will be done from the register R1 to R2. The transfer of information will be done from the register R1 to R2. See, if you see the symbol here, R1 is transferring the data to R2. Next, a very important symbol is comma. Separates two micro operations. Separates two micro operations. Suppose if I have an operation R1 tends to R2. Suppose if I have another operation R2 tends to R1. I have two operations here where I am trying to transfer the data from R1 to R2 and I am trying to transfer again the data from R2 to R1. We designate these two as separate operations, right? This is one operation and another one is second operation. So to say it as one operation is different from another operation, I should try to make a separation by using some comma. Without using this comma, if I write these two statements, if these two statements, if I write side by side, these two are not considered and these two operations are not executed properly. Means if I make it as a comma, then it indicates R1 is transferring the data to R2 and the next operation R2 is transferring the data to R1. So we have to remember while using this register transfer, the basic symbols are the letters, parenthesis, arrow and comma. Next, we'll see bus and memory transfers. So the, the part of registers we have seen how the data is stored in the registers, how the data is operated on the registers, and how the data is manipulated in the registers by using some operations, and what are the symbols we are used in the operation or the transfer of registers. Now we'll go to a transfer or bus and memory transfer. Bus and memory transfer. See, if I say it as a bus and memory transfer, suppose you have more than one register. Suppose if I have more than one register and all these registers are to be transferred at a time to another register. What I should do is I should try to make a connection. Right? So one by one, if I can't do the connection and I can't transfer the data. If I do that, the process will become very late. So a more efficient scheme of transferring information between the registers is considered as multiple register configuration or common bus system. Means if I have some 10 registers, what I will do is I will try to make 5 another way and 5 another way. We'll try to make this as a common bus system where all these 10 are connected to this bus system and the data will be transferred. Instead of connecting each register at a time, transferring that and again connecting register R2 and transferring that, what I will do is I'll try to make a bus system where this bus will try to connect all registers at a time and transfer the data. A common bus consists of set of common lines, right? A common bus consists of a set of common lines where these common lines use each bit of a register. So register contains bits, right? These bits will try to use these common lines and connect one another to transfer the data between the registers. Control signals determine which register is selected by the bus. Because all the registers cannot be selected at a time, where we will try to put a control signal, that is on and off, where this control signal will try to make a connection or will try to give a signal saying that register 1 is waiting for the transfer of information, or register 2 is waiting to transfer the bit from one register to another register. Right? Different ways of constructing the common bus. Suppose if I want to make a common bus for the registers, I use multiplexers and I use tri-state buffers. So one way of connecting a bus and memory transfer is using multiplexer, and another one is tri-state buffer. And the third one is common bus system with multiplexers. The frequent way of using and the regular way of using the transfer of data between the registers is considered as multiplexers, common bus system with multiplexers. So the registers what we are using here may be 4-bit register, or we can go with 8-bit, or some 8 register, or some 16 register, like that. Now, for example, if I take it as a common bus system with multiplexers, bus system with multiplexers, where we are going to use 4 multiplexers. See, for example, we'll try to see the registers are 4 and we are trying to connect these 4 registers to a multiplexer, where this multiplexer will try to give a single output for us. It will connect all the registers. Suppose if I say it as R1, R2, R3 and R4, all these R1 register to R4 register will connect to a single multiplex register and try to process the data and give the single output here as a common bus. So how this register or how this common bus memory system is working. Diagram what you are seeing here is multiplexers 4 and registers 4. So what we are trying to do is we are trying to connect all the registers bits to a multiplexer. All the registers bits to a multiplexer. Suppose if you see here in the register D, 3-bit is connected to multiplexer, and register C, the 3-bit is connected to the second one, the 3rd bit is connected to first one, and the 3rd bit is connected to the last one. Means all the 4 bits of each and every one register is connected to first multiplexer. Likewise, we try to make the connection of second one to the second multiplexer and the second bit of register C2 multiplexer. Likewise, we will try to make R3 and R4 also. Means each and every bit of one register is connected to multiplexer. Now, we will try to operate this and we will try to process the data for the transfer of information from all the 4-bit registers through a multiplexer to make it as a single output, or a 4-line common bus using a single output. See, the operation will be like the register contains, the multiplexers contains S1 and S0. S1 and S0. Whenever we try to operate this S1 and S0, these indicates that which register is selected. Suppose if I say S1 and S0 is showing 0 and 0. If I say S1 and S0 is showing 0 and 0, the register A gets selected. The next process, if I say the register 0 and 1, S1 is 0 and S1 is 1, then I can say it as the register B. B selected. Likewise, by the inputs of S0 and S1, we'll try to select the registers. Once if the registers are selected, that is 4 registers we are operating here, register A, B, C and D, all the data gets processed for register A, B, C and D. Next, for example, the output 1 of register A is connected to the input of 0. Right? The output 1 of A is connected to the register or to the multiplexer 1. Then the multiplexer 1, because the output is labeled as A1. Likewise, we will try to label all the outputs as A1, A2, A3, A4, like B1, B2, B3 and B4, where these designates the connection of data between the registers and the multiplexer. Suppose if I say it has 2 register is connected to 3, so it cannot be happened. Suppose if the register 3 is connected to multiplexer 1, it cannot be happened. So for the confusion, to make it clear, we are trying to make it as the designation A1, A2 and A3. See here, the transfer of information from a memory word to the outside environment is called as read operation. So now, once if the bus and the memory transfers are happened, now we'll try to see how the memory transfer is going to occur. The transfer of information from a memory word, to the outside environment is called as read operation. Right? The transfer of new information to be stored in the memory is called as write operation. Suppose if you want to store the data into the memory, which is called as the write operation. Writing means we are trying to store the data into the memory. Write operation indicates whenever you want to store some information, whenever you want to store some data onto the registers is considered as a write operation. Or whenever from information from the memory word, means we are fetching the data from the memory is considered as read operation. So these were the basic things which we have to remember while we are going to discuss the memory transfer. Next, a memory word will be symbolized by a letter M. A memory word will be symbolized by a letter M. Suppose if I say it as a read operation, suppose if I say it as a write operation, means when I say that with M, this indicates the memory transfer. It may be putting the data into the storage or getting the data from the storage. Next, the particular memory word among the many available is selected by the memory address of the transfer. As I told you, we have seen MAR register. What this MAR register indicates, the memory word among the many available is selected by a memory address during the transfer. Right? Yes. It is necessary to specify the address of M when writing the memory transfer operation. Means if I say it as M of A, means I am doing some memory operation. If I am trying to say it as the designated letter with the M of A or M of R, means I am doing some memory operation. That memory operation may be a read operation or maybe write operation. What this indicates, it is necessary to specify the address of M when writing a memory transfer operation. Means where it has to be stored. Suppose if I say it as a write operation, I am storing some data into the memory. If I am storing some data into the memory, that particular data should contain some address. Suppose if I say 1001, into this particular address, the data has to be transferred. Suppose if I transfer the data into this particular memory address, it is very easy to fetch for me, or it is very easy to me to get the read operation from that. If I am not doing such operation and simply if I am storing the data into the memory, while I am fetching the data, I should try to search each and every address. Suppose if I say it as from 0 to 1000, I should try to search all these memory addresses where the data is transferred. Instead of when I am trying to store the data, if I store the data into a particular memory address, which is considered as some numbering system 1001 or 1002, while I am trying to read that particular data, simply I can go to that particular address, MAR, and I'll fetch the data. It is very easy for me to get the information. This will be done by enclosing the address in square brackets following the Mlritm. Same thing. See like this. I'm writing the address here. So consider the memory unit that receives the address from the register called the address register, which is called as address register as AR. The address register is considered as AR register, means the address which you are going to store in the memory also contains some registers which is called as AR register. MAR is considered as memory address register. The address where we are going to store that particular data or store that particular bit of information is also considered as address register. Right? Next we will see the actual operations which are performed on the register. So as of now, we know how the data is stored in the register, in what way we are going to store the data in the register, and what operations we can do in the register, and how to store the data in the register. And also, if we are storing the data on the register, I have some symbolic representations for storing the data on the registers. Now, what we'll do is, if everything is ready with the registers, only the thing I should do is I should do some micro operations on that register. I should do some operations on that register. So what type of operations I can do? I can do here the register transfer micro operation, that is the transfer of data from one register to another register. Next, I can do some arithmetic micro operations, where the arithmetic micro operations are done on the arithmetic values. Means I can do some addition operation, I can do some subtraction operation, I can do multiplication, I can do some division. Whatever arithmetic operations are there, I can do the arithmetic operations on the data which is stored on the registers. Next, if I say logical, perform the bit manipulation operations. Logical operations means AND OR operations. AND OR, XOR, NOR, different types of operations are there. So all these AND OR operations, XOR operations, every operation is going to be considered as logical micro operations. So these logical micro operations are also performed on the data stored in the registers. Likewise, I can go to the shift micro operations also. What the shift micro operations will do? It transfers the data to leftmost position or it transfers the data to the rightmost position. It is left, it is right. I have some bits of information. So if I move that bits of information to the leftmost position, and if I want to move the position of the bits in the register to the rightmost position, then I should go for the shift micro operations. So all these types of operations I can do on the registers data. The data which is present on the registers, I can do the transfer, I can do arithmetic, I can do logical, and I can do shift operations. So how these are performed and how these register transfers, how these arithmetic, how these logical and shift operations are performed, we will see in the next class how to perform these each list of operations and how the data is transferred, how the data is operated, how the data is manipulated, and how the data is shifted. Okay. Thank you.